Hello, Professor. My name is Sayanaga Venkata Santoshi Nitya Bandaru, and today I'm going to do my final presentation. The topic I have chosen is loan prediction analysis, which means predicting the predicting the loan using machine learning models. So the reason for me to choose this topic is every individual these days find it more convenient to purchase any of the electronics, jewelry, housing, or transportation, or even to support the education through a process called EMI, which is nothing but a loan. As banking sectors are providing feasible loan plans, people are applying more for loans. And also, the major source of income for banking sectors is the loan, which is why it includes many steps of verification and validations. As many people from different backgrounds, such as rural, urban, and semi urban, apply for the loan, the company certainly wants to automate a real time process by having the customer's information while filling out the application form, such as their annual income, their marital status, their credit history, their bank account, and their source of income, everything. So, here my aim is to predict the model that works best in giving us the approval status of an applicant with respect to the banks. So, to begin with the data source, this data set was sourced from Kaggle, and it has two CSV files. One is the train and the other is the test. I am proceeding with the train.csv data file as it has 13 independent variables, which also includes my target variable, that is loan status. Now, before getting into the exploratory data analysis part of the project, I would like to explain you my plan of action, where it begins with collecting the data, cleaning the data, removing all the null values and checking for the duplicate values, and setting all the data to extract some of the insights which might help me in building the model, and then proceeding with the model building part and bringing out the best accuracy score of the model, where I can conclude that the best scored model will help me in predicting the loan status of an applicant. So now, moving on to the next slide, it starts with the exploratory data analysis. So the initial step was I checked for the duplicate values, and the data set I have doesn't include any duplicate values. Then I started checking for the null values. The data set had few of the null values, non values, which is why I decided to replace null values with mean and mode of the columns. I used mean for the categorical variables, and I used mode for the ordinal variables such as credit history. As there are more categorical variables in the columns I needed to predict the loan status, I used labeled encoder to convert it to, all it to the numerical variables. And after this part, the insights I was able to pull out is around 70% of the applicants has a clear chance of loan approval. After checking the status with the loan status column, I wanted to check the status with every individual column, which is why I adopted a process called univariate analysis, which means checking the behavior of each variable on the data set. So from all the bar plots, the insights that are extracted are about 80% of applicants are male, and married applicants had more fair chance in getting the loan approved. And the next point is there was a fair chance of a loan approval for the graduates and self employed than the undergraduates and dependents. And the next is semi urban area residents had more chance for the approval. As all these come under the categorical variables, I have separated the numerical variable, which is applicant income and co-applicant income, from the categorical variables, and plotted a frequency distribution graph for this. Looking at the graph, this shows that the applicant income is normally distributed. As I was a bit curious to know if